Hello everyone, my name is Pshtiwan Shakor. I'd like to discuss on this topic Inkjet Mortar 3D printing methodology and its application. As a casual staff at UTS and working with the Icon Smart and SPU. So as a beginning, I would like to let you know what we'll talk about today on the introduction and background on AM, which is additive manufacturing for construction, and I'll be focusing on the powder base or inkjet, sometimes called binder jet in 3D printing, and some differences with the extrusion 3D printing will be discussed. So later on we'll be going to talk on the mechanical properties such as compressed strength and flexural, and at the end we'll have a general summary. At the beginning, you can see there is many codes and standards for construction industry. The American Society for Testing and Materials, ASTM F42, that classified additive manufacturing into 7 classification. So basically we have that, material jetting, material extrusion, binder jetting, and powder beds fusion, sheet lamination, and direct energy deposition. For this study we are focusing on binder jetting, which is sometimes called inkjet, or sometimes they call powder based printing. As the large scale of inkjet 3D printing, there are many types of inkjet 3D printing. But at the beginning, the D shape, they started in 2004 by Enrico Dini, which is a magnesium-based material to print structures and architectural shapes for construction industry. Later on, each of the companies, VoxelJet and X1, they developed their materials and the machines to make a precise construction elements and members for construction. As the first 3D printed inkjet by D-shape was made by Enrico Dini. So he started to provide in the marine structures, archaeological structures, and aerospace application. So he also tried to input this application into construction industry as well. So basically the printing products in the D shape, they can print up to 6 by 6 by 3 meters, or sometimes elongated until 6 cubic meters, all the sides. So, and the accuracy of the layers, they can print up to 10 millimeter in a layer. So overall is about 2.5 cubic meter per hour. So that means this printing applications can be suitable for construction application, which can be used for the large scales as well. As a materials base for the inkjet printing or binder jetting, the most suitable materials that have been used earlier by Enrico Dini, it was magnesia-based materials. However, these materials can be used that I mentioned here. So those materials more familiar for construction industries, such as cement mortar, that have been used by Shakor from 2015 to 2021, and the other materials such as geopolymer by Gia in 2016 and gypsum by Asadi in 2016. The other materials like a quartz sand, it was developed by Manocha, that have been used in 2016, and the clay materials as well, that have been tried by binder jetting in 2018, and the wood-based material was tried in 2013 by such kind of inkjet 3D printing as well. As optimized for the materials and the printing process, it's necessary to think about which materials most suitable to be used in the inkjet 3D printing or binder jet in 3D printing, such as cement mortar and other materials. Here, as myself, that I've been using the cement mortar. To optimize this one, we need to calculate for the cumulative distribution and particle size distribution. However, the density distribution can be uh, can be observed as well for such kind of the printing. So here in this graph, you can see the blue line is representing the factory or manufacturing material that are available by the companies. So, and the black one, that is a cement mortar materials that have been used. It's quite close to the blue lines, and we have been replaced that materials, I mean cement mortars, instead of the ZP line, the ZP material, which is called the gypsum material. So the other things that we have really need to optimize is the thickness of the layer. So the thickness of the layer was studied by Mustafa in 2021, and I have been discussed as well in my one of my papers, how to do the layer thickness for the cement mortar material, and we have also optimized the saturation level. I've done this study from 2015 until 2020. So how to optimize this material and how to use a water cement ratio in a specific way that can be suitable for construction industry. Another thing is it should be necessary to check it on, especially for the materials and printing optimization. It's the flowability of the material. So we need specifically to optimize the flowability process, such as checking angle of repose. So we have been checked both of them, the angle of repose for the cement materials, the cement mortar materials, and the gypsum. They are pretty quite close to each other. So another thing is necessary to know as well, it's optimizing the speed of the process. So that each layer, when they print, they have a speeding process, or we can say delay in a printing process. So we check it for different time of printing process, and we get quite different results. As you see in the second photo on the left, so at the 100 millisecond, and from 200 to 300, we have quite different results, and we get a actually different kind of compressive strengths when the speed is changes. However, it's necessary to know as well that post-processing is a major necessary process to be done for the each printed material, especially for the cement mortar or any kind of material that need a higher strength. It need to be heating up, so, or the temperatures should be elevated in an oven to make the specimens more stronger and more stiff. Also, it's necessary to optimize this material in a curing liquid. So maybe we need a different type of liquid, but for cement mortar we have been using only water, and we are cured quite in a good shape, and get a very good results when we have cured in water. But some other materials such as geopolymer, we may need a different kind of liquid to get the better results in compressive strength after curing. We know the printing process, basically it consists of the following procedures to get the samples to be printed in a good shape. So the first of all, we need to have a feeder, and they have materials in. After the feeders going through a flowability process, and spread it into back of the printer. Then we need a bladder to send this material into the belt chamber to make the layer powders on the chamber. And when the gantry comes, the gantry they have a kind of print head on the head of the gantry to put the ink on the specific area until we get the printed shape at the end. As we know, for civil engineering and structural purposes, we need to know the compressive strength of the mortar, especially the mortars. When we have printed by this kind of printer, we need to know however working in a good way or not. So we need to print it in a good shape. And at the same time, we have tried to use not only the cement mortar in this kind of printer, we have put it the glass fiber that is called E6 glass fiber, which is very quite good to be printed with the such of the materials, especially they get very better results in a tensile. And after we checking these kind of materials with the glass fiber, we get a very good results for the cubic shape of the sample in 80 degrees of the treatment in a post-processing, and we get about 37.88 megapascal when we have 1% of the glass fiber in such kind of the printed sample. However, we couldn't put too much of the glass fiber in the specimen because the blocks that happen in the back of the chamber of the printer. So that's why we are trying to use minimum 1% to get a good result for such printed specimen. As we can see from here, it shows the flexural strength for the mortar with or without E6 glass fiber for inkjet printing specimens, and it clearly shows that the materials with a different saturation and different direction shows different results. That obviously shows in the 28 days that we get a very good results for the flexural strength with the highest saturation level. Here we means the saturation level as a water cement ratio. Basically for that water cement ratio we got about 0.52. It equals to 170% of the saturation level. We get a good results in that point when we have in a 28 days in X direction, because as we know even the printing materials we get orthotropic properties, not as a normal concrete that they have isotropic properties. Therefore, it's necessary to know that the printed material they get a very good result if we print it in a right direction and use it for the right purpose. Another tools it can be used for the 3D printing parts to be checked and optimized. It is a finite element analysis by using different software such as Abacus or Athena. For example, we have been used Abacus to check out our printed samples, and we get our results almost verified by the FEA as well. So we're seeing that the printed specimen that we have in a XY direction, it got a highest result, and specifically they have a similar results in FEA as well. So basically we can model any part of the printed part by the 3D printing in a FEA, and later we can check it in a laboratory, and we can optimize which directions can be used as well for the application in real life. To optimize the 3D printed parts, orientation angle, it is another topics in 3D printing. It should be considered as well. So any parts that we want to print in a inkjet 3D printing can be printed in any direction or even in any orientation as well. So here you can see from the figures how we can build the specimens with the 0 angle, 30 angle, and other different types of angle that we need. Herewith, in showing the orientation angle while printing has a major effect on robustness of the product in terms of the mechanical properties. It's not only effect on mechanical properties, but also in large specimen it causes a deflection in a printed structures. That's due to the heavy and bounded powders on the specimen, and for example we can see it in the printed part of the 45 degree and 37 degree as well. So furthermore, it is necessary to know as well that the highest compressive strength was obtained in a 0 degree rotation and in an XY plane, and for shear strength as well we got a very good result in 45 degree of orientation angle. So that means that's the optimum for us, as well as the in a tensile and flexural in a 0 degree orientation we got a very highest value, and therefore it's necessary to be considered those angle for our printed parts. Overall, the 0 degree, it's very good angle to be printed for our printed specimen. However, from perspective of each materials, maybe these angles will be different, and the purposes may be also affect on the results for what purpose we can be use it as well. You can see the results for the powder bed porosity. The powder bed porosity can be found by this formula as you see on the screen. So basically we can find it how it's different between those two materials when we are using the ZP or gypsum with the cement mortar materials. So basically we can find the powder bed porosity inside of them, that we can find that in gypsum about 64.9% and in cement about 73% the porosity inside the powder bed of the printed material. At the end, I want to show you the CT scan of the printed materials and how we clearly can see the inside of the materials and the saturated level for each of the specimen. As you can see on the left, you can see the fully saturated 3D printed material, and on the right you can see the partially saturated 3D printing. So basically the partial one, it is not putting the liquid on all the specimen, the entire specimen. However, in a fully saturated, they are fully saturated with the liquid material. At the end, I can conclude the remarked points of this printing technology. I can say the inkjet 3D printing is counted as the second most popular technique for construction industry in terms of this technology is called AM or additive manufacturing, and it can be seen that XY plane could be the strongest plane in the orthographic properties for the inkjet printing, and 1% of the glass fiber could be useful and could be used with getting a good result about 37 megapascal. The saturations of 170 in an inkjet 3D printing could achieve the very good strengths and higher strengths compared to the other levels of saturation level. At the end, I'd like to thank you for your attention, and if you have any question, feel free to ask me now, or you can send me via email. Thank you.